Hello everyone. In this video I will explain cellular network concepts. So before discussing cellular network, uh, let's discuss traditional approach which were in use before cellular network. So in this approach there were only a single transmitter which installed on a very high location, and that only one station cover entire region. So the range of the signal for that transmitter was up to 50 kilometer, and this system achieved good coverage because we are having only one transmitter, and this one, in order to cover a good amount of region, in order to cover this range, this transmitter need lot of power. So these are the points of this traditional approach: single transmitter but very powerful, and only one transmitter used to cover entire region. Now the problem with this approach was, if a frequency used in the region of this coverage, that same frequency cannot be reused by other users. So frequency reuse concept cannot be used in this situation. Second, this transmission need to be very powerful. If this is not powerful, it cannot cover entire region. Now, what cellular network suggested? Cellular network suggested that instead of having a single transmitter, why we don't go for multiple transmitter with low power. So in cellular network, instead of having a single transmitter, a single station, we are having a multiple station. Now these stations are not as powerful as we have seen in the previous slide. So these transmitters are less powerful, they are having less power. So because of this reason, they can cover a particular area of a region. So this hexagonal shape is actually showing which area they are covering. So this station is covering this area, this station is covering this area, this station is covering this area. So in cellular network we are having multiple transmitters. So instead of using single powerful transmitter, use multiple low power transmitter. These transmitter are actually used for transmitting and receiving both purpose. So this is also known as transceivers, and we call them base station. Now every base station, if you look at the GSM network, so these BTS can cover only a particular area, and this circle is showing that range. So that area is known as cell. So this station is responsible for covering this area. So this is cell, one cell. This is second cell, third cell, fourth cell. Now, if we are having some frequency, let's say that total frequency is T, and we are having four base station. So every base station will be getting T by 4 frequency. Okay. So channel per BTS. So if you want to find out how many channels we are having in per cell, so first we will find out what is the portion of frequency allocated for one cell. So formula for that one: available bandwidth, number of station. So it will give us frequency amount which is allocated per cell. Now how much frequency required by one channel? So that thing, if available, we will divide that number by the allocated frequency in one cell, and it will give us number of channel in per cell. So this one we have already discussed: coverage range of base station, also known as cell. Now when we are having multiple base station, as you can see in this example, and our user is mobile, a user is talking while he is driving the car. So some point of time, that user is connected to this base station, here this is connected to this base station, here this is connected to this base station. So when a user change its location, when he moves from one cell to another cell, so another cell base station has to handle now traffic of this user. So this thing complicate the cellular network a little bit. So this thing also known as, we will study this one under handoff. And the another thing, when we are having multiple base station, so these base station at their boundary, their frequency actually interfere. There will be some interference. So in order to remove this interference, frequency in adjacent cell has to be different. If they will use same frequency in adjacent cell, there will be a interference. So same frequency should not be used in adjacent cell. So these are the points which we have discussed so far. In cellular network, instead of using single powerful transmitter, use multiple low power transmitter. These transmitter also known as cell. These transmitter also known as base station. Every base station can cover a particular area of a region. That area is known as cell. And channel of neighboring cell, it means frequency allotted to this cell and frequency allotted to this cell has to be different, otherwise there will be a interference. Now here I will explain why this hexagonal shape is considered to represent a cell. So there are some criteria, like which cell has to be used. So these are the three criteria. First criteria, whatever shape you are selecting, if we use those shape multiple times, there should not be any overlapping in order to cover entire region. Second, it has to be a geometric shape like square, rectangle, circle. And third, area of cell. So whatever shape we are selecting, it should cover maximum area. So let's see, we are having the uh, possible options. There are other options as well, but we are going to discuss only these one. So if we go for circle, if you try to cover entire area, there will be overlapping. So that's why this option will be rejected here itself. In case of triangle, there won't be any overlapping. Hexagonal, no overlapping. Square, no overlapping. So now we are left with three options. Now all these three are geometric shape. So second criteria also fulfilled. Now we are going for area. So in terms of area, this shape provide maximum coverage, but this option is already rejected. So we are considering area of the shape as compared to circle. So this triangle can cover this percent of area of that circle. Hexagonal can cover 83 and square can cover 63. So hexagonal shape, if used to represent cell, it can cover maximum area. So that's why hexagonal shape is selected to represent a cell. Now why cellular? So there is a advantage of cellular network, that if there is an increment in demand, like if the number of user will increase, traffic will also increase. And in order to resolve this problem, more base station can be installed without buying extra frequency. So how this is possible? So there are concept of frequency reuse. A frequency which is used in a cell, same frequency can be used in another cell if distance between these two cell is a particular, uh, there is a criteria actually, that if you are going to reuse a frequency in another cell, they must fulfill a criteria. So we will discuss that formula, how to find out that distance. So scalability issue can be handled in cellular network very easily. So like if here it is showing like we are having a base station here, and we came to know that number of users are increasing. So we installed one more base station and we have used same frequency in that cell, and we are assuming that signal of these two base station will not interfere. It means this distance has to be large enough so that their signal will not interfere. This same frequency can be used here, the same frequency can be used here. So in cellular network there is a big advantage of frequency reuse. Okay, channels can be reused. This is a very big advantage, and this is distributed throughout the geographic region. There is no single transmitter who is handling entire traffic. There are multiple base station, so there is no central control. Like if we see this point, use of several carrier frequency, not the same frequency in adjoining cell. So if a frequency is used here, that same frequency we can reuse in another cell far enough so that there won't be any interference, but it should not be used in adjacent cell. Hexagonal shape of cell, it idealized, we have already seen why. And if a mobile user changes cell, there will be a handover. Okay, so we have seen these points. So the problem is that, first thing, as the number of base station will increase, when user will be on active call and he is moving from one cell to another cell, so there will be a overhead for transferring an active call from one base station to another base station. So this process is actually known as handover. And second one, interference with other cell. So before going to reuse a frequency, we have to first see whether two co-channel cells are far enough or not. Now let's see this handoff concept as well. So we are having this example. Let's say user is driving and right now he is here and he's on the call. So right now he is connected to this base station, and while he is driving, when he entered in another base station, his call will be transferred, or his call will be handled now by this base station. So transferring an active call from one base station to another base station is known as handoff. Okay, it can be active call or it can be active data session. So whenever there will be a transferring from one base station to another base station, this is known as handoff. And we are having two types of handoff: hard handoff, soft handoff. In hard handoff, let's say this example, then it will make this concept clear to you. Right now a user is here, he is connected to this base station. Sorry. So when he move to another cell, so what will happen? First this connection will be broken, and then this new connection will be established. So you can remember this one like break before make. So in this base station will start handling its traffic once this is disconnected from the old base station. So this is the hard handoff. And soft handoff, in soft handoff, when a user move from one base station to another base station, so at the boundary of cell, this uh, user will start getting signal from a new base station, and as that user moves to this cell, signal of previous base station will become weaker. So what will happen, that uh, user will be connected to this base station, mobile device, mobile node, that will be connected to this base station. Once this connection is done, at that time this connection will be broken. So here, before breaking the old connection, a new connection has to be established. And as it's written there, it's more costly than hard handoff. Why? Because there will be a situation where one user will be connected to two base station, and in order to do that it needs two different frequency. So because of this requirement, this is costly than hard handoff. Thank you very much for watching. In next lecture I will explain how to frequency can be reused in cellular network.